MS Ramaiah University of Applied Sciences.
Hello students, let us discuss about the measurement of strain produced from an applied load using a strain gauge setup. This experiment aims to determine maximum principal stress, minimum principal stress, maximum principal strain, minimum principal strain and maximum shear stress using a strain rosette in a circular beam of star and delta rosette. The strain gauge setup consists of aluminium circular beam fixed at one end, hanging hook with flat aluminium beam, strain indicator and standard weights. The principal plane on which normal stress attains its maximum and minimum value by the application of load, and in this plane shear stress will be zero. The extreme values of normal stresses are possible in the material which are called as maximum principal stresses and minimum principal stresses. Likewise, extreme values of normal strains are possible in the material which are called as maximum principal strains and minimum principal strains. In this experiment, the strain values will be measured in a local coordinated systems. Based on the application of load on circular beam, the material get deformed and will get strain values. Based on the application need, strain gauges are mounted at different locations to measure the strain values, normally get the tensile and compression strains. Two types of strain gauge rosettes are as follows, which in the form of delta and star configurations. In delta rosette, 3 strain gauges will be mounted with an angle of 60 degree. In star rosette, 3 strain gauges will be mounted with an angle of 120 degrees. The apparatus required to conduct the load cell experiment are strain gauge, hook, weights, digital strain indicator apparatus and circular and flat beam to complete the circuit. The procedure for carrying out this experiment as follows. Note down the material of the specimen, Young's modulus and Poisson's ratio. Connections to the digital strain indicator from strain gauges are made in the system. Channel selector positions for delta rosette 1, 2, 3, for star rosette 4, 5, 6. Set the channel selector to first position. Note down the type of strain mounting. Adjust the indicator to 0 by operating the knob in clock or anti-clockwise direction and press for Cal button till the indicator displays CAL. Then release the button. C display shows 0. Load the specimen by loading weights up to 2 or 2.5 kg. Note down the strain value in the digital indicator and tabulate the readings. Repeat the above procedure for different loads. Change the channel selector to 2nd, 3rd, 4th, 5th and 6th positions and repeat the same procedure with the loads used in previous readings with respect delta and star rosette. Calculate the required parameters by using formulas. The readings obtained from the experiment must be tabulated in the format of a tabular column. Carry out the calculations using the standard formulae of reading a strain gauge. Find the error in reading as well as the sensitivity value of the instrument. This experiment has its own limitations. Setting 0 value in strain indicator for calibration is quite challenging due to electrical losses and mechanical impact of experimental setup. Whatever strain values getting from setup is from local coordinate system, not from global coordinate systems.
Hi students, name of the experiment is strain gauge setup. So aim of the experiment is you are going to determine maximum principal stress, principal strain and minimum principal stress, minimum principal strain and shear stress. The operators required for conducting strain gauge experiment is: one is strain gauge setup, and the strain gauge setup consists of mains on. The mains on indicates that the power supply to the strain gauge setup. Strain indicator. The strain indicator, it is a display indicating the strain values based on the application of the load. Console on. The console on, it indicates that whether setup is in running condition or not. Calibration button. The calibration button, we are going to calibrate according to the channel selector. Find zero knob. The find zero knob we are going to use to set zero value in a strain indicator. Then we are going to use the calibration button. Channel selector. The channel selector, that indicates that in this experiment there are two channels. One is star reset, another one is delta reset. So in each reset there are three channels. So from this knob we are going to use to select. And this is circular aluminum structural object. It is fixed at the one end and free at the other end, where we are going to apply the load. Okay, so on the top and lower side of the aluminum structural member, there are 3 strain gauges mounted on the top and the 3 strain gauges mounted on the bottom of the structural member. So it is in the form of, the upper portion is in the form of delta shape, it is in the lower side, it is in the form of star, and each strain gauge in the delta reset, it is placed with an angle of 60 degree. In the bottom side, it is placed with an angle of 120 degree. The main aim of the strain gauge mounting at this point is to measure the strain values. So here in the star reset as well as in delta reset, you will get a 2 tensile strains and 1 compression strains based on the application of the load. And hook, it is a hook, we are going to put the load on this particular member. And then standard weights. These are the standard weights or load we are going to use to conduct the strain gauge experiment. Now let us start the strain gauge experiment. Before starting the strain gauge experiment, first you have to set the channel selector position. The mains on indicates that power supply to this setup. And console on, it indicates that the setup is in running condition. Okay, once you switch on the console on, next you can move on to the channel selector. The channel selector, it tells the position of the strain gauge according to the different resets. There are 2 types of resets. So one is delta reset with a 3 strain gauges. It is mounted on the aluminum structure member at the top. And another one is the star reset. The 3 strain gauges, it's mounted on the bottom of the structural member. So now you can see this. The first position that indicates that the delta reset, the first strain value we are going to measure it. The second position, the second strain value we are going to measure it, and third position, the third strain value we are going to measure it based on the application of the load. So next in star reset, again this is first position in the star reset, again you are going to measure the strain value. Second position in the star reset, again you are going to measure the strain value, and third position in the star reset, you are going to take the strain value in the particular position. Once you set the channel selector positions, next you can move on to the find zero knob to calibrate the strain gauge setup. Okay, so you have to use the find zero knob to calibrate the strain gauge experiment. Once we set zero value in the strain indicator by using find zero knob, then you can press the calibration button to calibrate the experiment. Once you press that, it has to show the zero indicator. That indicates that we calibrated the experiments. Okay, once you calibrated this, then you can apply the load with respect to the position of the reset. So now I am going to apply the load with respect to the different combination of the weight. So I'm going to apply the load on the hook. What is the strain value you are getting? You can take the strain value with respect to the different positions. Now you can see this. So with respect to the first position of the delta reset, so what is the strain value? It is showing that -3 in micro strain. That is nothing but -3 into 10 to the power of -6. Okay. Now again you can change the position, or maybe you can take the different load. So this is for the 0.5 kg. Now I am applying with the 1 kg. What is the strain value you are getting? Again, if you apply the different load, that for 1.5 kg, what is the strain value you are getting? Just note down with respect to the application of the load and what is the strain value you are getting. Once you noted down the strain, different strain value based on the different weights, so now I am going to change the position of the channel by removing all the weights. So you have to continue this experiment by changing the channel position according to the reset whatever you used. So now I change the channel selector. It is there in second positions. Again you have to follow the same step what we followed in the first position. So what we followed in the first positions, again we adjusted the fine zero knob, and again you have to calibrate the experiment. Okay. Now according to the second position of the channel selector, we adjusted the fine zero value in the strain indicator by using fine zero knob. Then again I am going to I will press the calibration button to calibrate the experiment in the second position of the delta reset. Now you can see after the calibration it has to show the zero value in the strain indicator. Now I am going to apply the load in the second position of the channel selector to measure the strain value. Now you can see this, I applied 0.5 kg, then what is the strain value you are getting? It is 2 into 10 to the power of -6 microstrains. So again you can try for different load. So what is the value you are getting? It is a 3. So one thing you have to observe here, in the first position of the previous experiment we got a negative value, and in second position we are getting a positive value of the strain indicator. That indicates that, so it is in the earlier case it is under compression, and now in the present status it's showing that it is under tensile. So we measure the strain value in the delta reset. So similarly you can want to measure the strain value in the star reset, apply the different load and you can measure the strain value. So this concludes the strain gauge experiment.
At MSR UAS, we spark your imagination unlike any other.